dui by d tau plus gamma by this thing uj is equal to 0. Clear? So this is the equation what we have derived, and I have told in the last lecture there was a minus sign error. Huh? So there is no minus error. The reason being we have defined this gamma in a wrong way. Huh? Okay, so like this thing. So in the last lecture we have defined this gamma like this. Ijk is equal to half GIL, let's say partial L, this L, then you are having this GJK, okay, minus partial J GKL minus partial KGLG. Is it? This is how we define it, this gamma. Clear? Samajh hai? But the point is that, so the minus sign which we had problem earlier, so it is actually, this gamma is defined in this fashion. You put a minus sign on this side and plus here. Clear? So that means you have taken minus out. So this was actually like this thing. If you remember, it was like this thing. Yeah? So this will then be actually equal to minus. So it is this very minus. Yeah? Got it? So there was no minus sign error in the last equation. Only the point is that the way we have defined this gamma, so okay, had the problem with the minus. Now you have to define actually minus here. You actually take minus out here, so that on the very first term you put a minus sign, other two terms you put what? A plus sign. Okay? Clear? Got it? Okay, so now let's look at the non-relatives limit of this very equation. So what does that mean? So when I take the non-relatives limit, what it means? So we are actually in the weak gravitational field. This equation holds for any strong any kind of gravitational field. Clear? So we are in the weak gravitational field. Samajh? Okay, so let's take that very limit, and moreover, the motion of the particle is slow in comparison to the velocity of the light. V by c is very less than 1. Okay? Okay, so now how to proceed that? How to figure out a non-relatives limit of this very equation? First tell me if this is a geodesic equation, is it? Or in other words, we can say it is the equation of motion of a particle on a curved surface background. Okay? Samajh? Or rather on a curved space-time. So if I take a non-relatives limit, where it should go? So it should reproduce actually the Newton's equation of motion, is it? In presence of a potential. Samajh, what kind of equation we have? So it should actually go to this kind of equation, d2, let's say r. Let's write d2r by dt2 is equal to minus gradient of potential. Phi is the potential. Okay. So this is the Newton's equation of motion in presence of the potential phi. So the non-relatives limit of that equation should go to this very equation. So it means then this equation correctly describes the motion on a curved surface. Samajh aa? So let's take the non-relatives limit. Okay, first tell me how to start doing the non-relatives limit. So I have given you the idea. So we'll consider a weak gravitational field. Okay, so what does that mean? At a given point, let's say if you are hanging at a given point, okay, so you assume at this very point as a weak gravitational field. What does that mean? So I can approximate the field, the gravitation, okay, I can approximate the metric at this very point as a Minkowski space metric, is it? Because when you take the non-relatives limit, what does that mean? At a given point of the space-time manifold, I should say at a given point of the space-time, so in the neighborhood of that very point, the space-time should be flat. So when it is flat, what does it mean? You are actually without gravity. So when you are without the gravity, what does that mean? You are having actually a Minkowski space-time. Because we are dealing with the space-time in general. So when I am taking a given point and around that very point or in the infinitesimal neighborhood of that very point, I am assuming gravity to be weak. Okay. So in other words, I can approximate the metric tensor in presence of that very point as a Minkowski space metric plus some correction that will describe that V gravitational field. समझ आया? You got it? Huh? Okay, so what I mean by that? Okay, so let me write. So this is the way I can go for the non-relative fluid. Let me write. In absence of this thing, gravity. So when you don't have the gravity, what is the space-time? How it looks like? Space-time has a Minkowski structure. Minkowski geometry. Okay, represented by metric. Let's write that metric as eta ij. Clear? So what is that metric eta ij? So it is simply diagonal minus 1 plus 1 plus 1 plus 1 in 4-dimensional space-time. Okay? समझ आओ? Okay. So therefore I can write a V gravitational field corresponds to a region of space-time. Everybody is getting this point? That is only slightly. So slightly, so let me put it within the quotes, okay? So like it's slightly curved. So although you can't do away with the gravitation, is it? So that's why I have put what? Slightly curved. Okay? In other words, I can say, so there exists a coordinate system like this thing. Since we are dealing with actually the coordinate transformation, I need to figure out actually a coordinate system. Huh? So there exists a coordinate system. Such that I can write this Gij metric as eta ij plus hij. Where eta is what? The Minkowski space metric, and h is the correction, this which provides you the slight curvedness of the space-time. Okay, so here the magnitude of this hij is very less than 1. So it is a very small quantity. समझ आया? Got it? Such that you can ignore order of, so you can ignore actually order of x square terms. Okay? समझ आया? So that means in the neighborhood of this very point, while you are approximating your gravity by the Minkowski space geometry, so there is this slight, you can say a perturbation, okay, or you can say a slight curvature represented by this hij. The form of hij is immaterial for us here. So we will just say there is an hij. We don't require what is exact form of hij. Okay. So let's keep it as such. It is function of some coordinate. Okay. So also now when I say this kind of thing, now I will assume in the neighborhood of this very point, the space-time is stationary, or in other words, it is static space-time. Why? So let's say if this is 0, this very term, this hij is 0. What is the space-time? It's a constant thing, so that means you are having a static space-time around in the neighborhood of the point P. Clear? Or this point while we are approximating the V gravity. समझ आया? Are you getting my point? So when I am saying, okay, so let me point this way. Around this very point, while I am approximating my metric tensor as that very form, I am saying the space-time is actually constant, okay, or it is static. So in other words, the time derivative of the metric itself is 0. Is that true? When I am saying it is static, so the time derivatives will vanish. Clear? So okay, so this will be another thing. So it's not only this, it implies actually this very point implies. So you say you are having static space-time are this such that the time derivatives of this g ij is equal to 0 for all ij. Ij goes from 0 to 3. Is it? 0, 1, 2, 3. समझ आया? Clear? So when you are having time derivative of this metric tensor to be 0, it means the metric tensor does not vary. Clear? समझ आया? It is a constant in that case. And what is the non-relative limit? How we define it? The velocity of the particle v. So by c it should be less than 1. समझ आया? Clear? Okay, so how we define the velocity? Now tell me. Since I am having a particle, I have to define in the frame of reference of the particle itself. We need to define the velocity vector in terms of what? Frame of reference of the particle. So that means I have to take the proper time of the particle. So what does that mean? So let's say u is the velocity of the particle. So let me write the special components. So alpha is equal to 1, 2, 3. So these are the special components of the velocity. So it is defined like this thing. So dx alpha by d tau. Okay. So this is how we define the special components. So this should be what? Less than c. Okay. How we define the velocity of light? So we will define it in terms of the proper time. Clear? So how we define it? So you have to move in the frame of reference of the light. Clear? So let's take this for the time. Is it clear? This very point? Okay. So let's move ahead. So let's do the calculation. Okay. So now let's start from this very equation. So you are having dui by d tau plus gamma I j k. Then you are having ui ug. Clear? It's equal to 0. So let's start with the equation. So I'm having the non-relative limit v by c very less than 1. Okay. So now let's extend. Let's calculate the components from here. So let me write this way. So du by d tau plus, since there is a sum over j and k, clear? J and k are summed over, sorry, it's not I, it's j, it's k, I'm sorry. Because these two indices are summed over, okay? So it contains both temporal components as well as what? Special components, okay? So let's write that. So it is tau, so 0, 0, u0, u0. Can I write it? So when j goes from 0, j goes from 0 to 3, k goes from 0 to 3. So you take first term, so 0, 0. Another will be like this, gamma I. Let me write alpha, beta. So there is a sum over alpha, there is a sum over beta. Clear? So what is the sum over, okay? So alpha goes from 1. So these are actually special indices. So in other words, these are actually the special components of the velocity vector. Okay? Got it? Okay, so now what is u0? So u0 is actually dx0 by d tau. Clear? So how much is that? C dt by d tau. Okay? Now what this u, okay, so let me write it. Okay? So now let's look at this very term. So this u alpha is what? Less than c. So in other words, now what is the magnitude of this very term? So it is actually c square term. This is actually u square term, is it? So in other words, the u square by c square is less than 1. In other words, this is what? The magnitude of this term is smaller than this term. So so that means I can ignore this very term. Can I ignore? Because it is the velocity, 3 velocity of the particle, and that is very small in comparison to the velocity of light. समझ आया? Clear? Any problem? Okay, so this can be ignored. So we can ignore this from this very condition. Okay? So now let's look at these two terms. So you are having now BUI. So let me write now. Let's take I is equal to 0. So that means 0 component equation. Okay. So let's take I equal to 0. Or you can, okay, so let me write what is that equal to. So in other words, let's take that gamma I 0, 0. Let's take this very object. What that is equal to? What is that? Half of GI, let's write L. So minus partial L. Then you are having these indices. G0, 0 plus partial 0, G0, G0L. Then plus partial 0, GL0. Clear? So let's evaluate this very object first. This kind of. Okay. So there is a sum over L. L goes from temporal and special indices. So I can write this in half. So G, okay, I0. Can I write it? Then I can put it as minus partial 0, G0, 0 plus partial 0, 0, 0, partial 0, G0, 0. Then you are having another term plus half Gi alpha. Alpha is a term. Okay, alpha is an index. It's a special index. There is a sum over alpha. Okay, minus partial alpha. You can write actually 1 here. Gi1. Next term will be Gi2. Another will be Gi3. Plus partial 0. G0 alpha plus partial 0. G alpha 0. Okay. So now the condition we have set, our metric is static, is it? The space time is static. What does that mean? The time derivative of the metric is what? 0. So what this object is? Partial 0 acting on, so this is 0. This object is 0, this object is 0. So that means this very term, so this is equal to 0 by assuming, metric, space time to be static. Space time to be static. Okay, so that, this goes. So this entire term goes. Now let's look at these very terms. Partial 0, G0 alpha. So this also 0 by the same argument. This also 0 by the same argument. Clear? So what remains? So therefore I can have this gamma I0, 0. So that's equal to half of Gi alpha. So you can take, okay, so minus partial alpha G0, 0. This, why this is not equal to 0? Because this is actually this space derivative of what? The metric, is it? Summation, we are only assuming metric to be static. So it can be fluctuating in the space. So there can be the space dependence. Okay. So now let's take I equal to 0 here from this very equation. Okay. So let me take this thing. Gamma, let's take 0, 0, 0. Okay. So that means this I am putting what? 0. So what is that equal to? So it's minus half of G0 alpha. Then you are having partial alpha 0, 0. Clear? Samashima, what is the alpha? Alpha is the special index. Clear? So Samashima, now tell me what is G0 alpha. Since G is a okay, so what is our G here? So we are using Gij is equal to eta ij plus hij. Clear? Okay, so let me erase it. So tell me, so it is gamma 0, 0. It's minus half of this I can put as eta 0 alpha plus h 0 alpha. Can I write it? So then I can write partial alpha. This I can put as eta 0, 0 plus h 0, 0. So can I write it? Okay. So what is that equal to? Okay. Now what is eta 0 alpha? Eta is a diagonal. So this is an off diagonal term. So this is equal to what? 0. Because what is the structure of eta? It's minus 1, 0, 0, 0. Then you are having 1, 1, 1. Clear? So all off diagonal terms are 0. So this is 0. Clear? And what this eta 0, 0 is? It's minus 1. So differentiation of that is 0. Clear? So now what you are having at hand? So what you can do, since if you look at this thing, this very matrix, so it's minus half of h0 alpha partial alpha H00. Can you see it? Is it? So now what is the order of this very term? So this you are having H and H, is it? So it's order of H square. Since we have said we can ignore actually order of H square term. So this is actually order of what? H square term. So that we ignore. Right? So in other words, up to the order of H square, this gamma 00 is 0. Essentially, huh? We will ignore in our calculations order of H square terms. समझ आवा? Clear? Because H is very small. What is the order of H square? That will be negligible. Clear? Now let's go to the another elements. Okay. So let's take this thing gamma. Let me write beta. So that means the special component. So it is equal to minus half of G beta alpha partial alpha G00. Is it clear? So can you tell me when it is non-zero? What are the terms which are non-zero? Because alpha, beta and alpha is having the same values. Clear? समझ रहे? So beta goes from what? 1 to 3, alpha goes from 1 to 3. So that means this G, okay, so let me write in terms of eta again, minus half of, so it is eta, beta alpha plus H, beta alpha and partial alpha, what is G00? So it is eta 00 plus H 00. Clear? समझ आओ? Now let's take, so this very term, H partial alpha H0. So that's order of H square. Clear? And what is the derivative of eta 00? This is a number, huh? So it's 0. Clear? So what remains there? So this I can approximate as minus half of eta beta alpha partial alpha eta 00. Sorry, H00. Because eta 00 differentiation is 0 plus order of H square. Can I write it? Can I write it? Okay, so this multiplied by the derivative of this thing, it is H00. Then you are having other term H partial alpha H, is it? So that's H square. Clear? समझ आया? Okay. So now tell me which is the term which will survive here when alpha and beta are same. समझ आया? In other words, when alpha is equal to beta, okay, so that means it will be eta beta beta. So partial beta H00. समझ आया? Everybody got it? Your servant समझ? So that means this, there will be only the diagonal terms which will be surviving. What does that mean? So in other words, I can write like this: partial 1 0 0 is equal to minus half of eta 1 1 partial 1 H 00 partial 2 0 0 is equal to minus half of eta 2 2 partial 2 H 00. Then you are having partial like this thing minus half eta 3 3 partial 2 partial 3 H 00. So in other words, if you see, alpha the element of this. So what is this? It is the special d by dx of H00, is it? So this is d by dy of H00, d by dy of, sorry, H00. In other words, this is actually the gradient of H. So you can say this partial, okay, so this gamma beta 00 is equal to minus half of gradient of H0. समझ clear? So this is simply the gradient. That's why I have put it in the express form here. Okay, so now let's move to the equation back to the equation what we have. Okay. So this is the equation we have: dui by d tau plus gamma I 0 Then you are having c square dt by d tau square. That's equal to 0. Clear? So now let's take I is equal to 0 part. So take I equal to 0, what you get? So du 0 by d tau. Clear? Is it true? So plus. So what is du 0 by d tau? Anybody can tell me? What is u0? C, is it? So what it will be? It is 0. Because C is a constant, yeah? So that means this term will be 0. So what you get? that true? Huh? Is it true?
IGP.
Malaiko, just tell me. Zeros, so it is like this: du0. Okay. Let me write this equation this way. So can I write it d like this? D tau plus gamma I 0 0 c square dt by d tau whole square. Can I write it? Can I write it? Because ui is actually a differentiation of dx by d tau, so it is not equal to 0. So now what this object is here for, okay, I is equal to 0. What I am having? d2 x0 by d tau 2 plus this is gamma 0 0 c square dt by d tau whole square. Okay, so now this object is equal to 0. समझ आओ? So what this gives me? So x0 is ct, so it is simply c d like this, d tau. Okay, so that's equal to 0. Or in other words, I'm having simply like this. So it gives me actually the relation between t and tau. So t and tau are linearly connected, is it? So in other words, t is actually the constant, the function of tau. समझ आओ? Is it true? So now let's take I is equal to alpha. Let's take, so everybody has written it? So let's take I is equal to alpha. For I is equal to alpha, that means 1, 2, 3. So you are having G. Can you tell me what should I write? Huh? U alpha. Okay, so let me write this thing. D to 2 x alpha by d tau 2 plus gamma alpha 0 0. Then what was that? C square dt by d tau whole square. So that's equal to 0. Clear? समझ हुआ? Can anyone tell me what is the dt by d tau? Anybody remembers this formula? Because here the special theory of relativity is applicable at that point, because we have approximated the flat space time at this very point while we are doing this analysis. Okay, so can anyone tell me what is this dt by d tau? So this is actually equal to dt by d tau is equal to 1 divided by root of 1 minus v square by c square. Since v by c is what? Less than 1. So this is approximately equal to 1 for v by c being less than. समझ आओ? Because the proper time and the coordinate time will match when a particle is moving slowly. समझ आओ? In comparison to the velocity of light. So this is equal to 1. What we are having therefore? So which implies gt2 x alpha. So this is the alpha, the component is equal to minus c square gamma alpha 0 0. What is this gamma alpha? Minus c square. Now tell me. So that is half, and there is a minus, so it will make it plus. Is it? समझ आओ? So what you are having there? Partial alpha beta, then beta alpha beta partial beta, then h0 0. Clear? Is it true? So what this object is? Can you tell me? So it is actually the alpha the direct. Okay, alpha the element of the gradient. Is it? So because this is d by dx, is it? So this I can write something partial alpha. Okay. So this is the alpha, the component of the gradient. Okay. So therefore I can write. So I can write this d2 x alpha d tau is equal to c square by 2. Okay. Partial alpha. Can you write it? Can you write it? Or in other words, what you can write, or you can write d2 vector x. Now let's put in the vector notation. It is c square by 2 gradient of s. Can you write it? Can you write it? Now if you see the left hand side is what? Left hand side is the same as what we are having the Newton's equation of motion, is it? Is that the acceleration of the particle? And what is on the right hand side? Gradient of h00. Now if we compare it with, let's say, the Newton's equation of motion, okay, so what we have, so what is our Newton's equation of motion? So our Newton's equation of motion is dx by d tau 2, so that's equal to minus gradient of phi. Is that true? So what it implies then I can identify that h0 with what? This phi. Can I identify? What is the phi now? What is h00? So then I can write this h00. So we can identify comparison like this, 2 phi by c square. Okay? So now you put h00 as 2 phi by c square in that equation, you will recover this equation. Rather minus, eh? Is it? Is it true? Are you sure? Huh? Is this equation correct? First tell me, minus delta phi. Now is this equation okay? Huh? Is this okay? Now if I use h00 as 2 times phi by c square, what I will get? C square will cancel, 2 and 2 will cancel. What it gives me? Gradient of phi. So I need to put actually a minus sign here. Samajh aa? When I put the minus, so it will be actually minus gradient of phi. So that means if I identify the 0 element of this h, okay, or the temporal component of this h to be the potential, the Newtonian potential, then I can say my this non-relativistic limit is valid. So samajh aa? So we have identified what? The 0 element of h. This is very important. Only this component. So what was our g? Now tell me. So we are having this gij as eta ij plus hij. Clear? So now let's take the 0 element. So it is eta 00 plus so h00. Clear? Samajh aa? So what is eta 00? It's minus 1. So it's minus 1. What is now h00? It's minus 2 phi by c square. So that's minus 1 plus 2 phi by c square. So now if you look at the matrix, which component gets affected in the gravitational field? Time component. Because in the gravitational field, the clocks tick differently, is it?
Yes.
So the clocks get slower down in a gravitational field. Is that true? So which component is getting affected? Only the tempo. That's why you are having only the h00 non-zero. You got it, huh? Samajh aa? Everybody got it? Huh? So now, okay, look, what is the Newtonian limit? Now tell me. What is the Newtonian limit? C tends to infinity, is it? If you take C tends to infinity, what happens to this very factor? This is 0. So you retain actually the flat space-time, huh? But it's not, your manifold or the curved space-time, what you started with, it is actually flat in the infinitesimal neighborhood of a point, is it? Or samajh, where, if you remember, when we started discussing, can we attach a local inertial coordinate system to a given point in a general space-time curvature, is it? So how we did that? We can approximate it by the Minkowski space matrix plus the second derivatives. The first derivative of the matrix was equal to 0. You remember that? So you can think up to the first approximation, I am having this very correction. Samajh? When you take actually C tends to infinity, that means complete the Newtonian mechanics you are having. So this is equal to 0. In Newtonian mechanics, what you are having? The space is completely flat. Samajh? Or space-time is completely flat. There is no curvature. Samajh? Clear? Got it? Okay. Any question? So have you understood the non-relativistic limit or the Newtonian limit of the equation? Okay. So let's move ahead. So now let's go to this Christoffel symbols or these affine connections. let's try to understand its transformation rule. I have told you these symbols are not actually tensors. So you are having this gamma jk. So it is equal to half of GIL minus partial GJK plus partial GKL partial. Okay. So if you see there are how many indices? 3 indices. You should expect this should transform as a tensor, but this is not a tensor quantity. So samajh the way, if you remember, under a general coordinate transformation. Under a general coordinate transformation, it is not a tensor. If you look at the Lorentz transformation, it will be a tensor. Lorentz transformation are linear, but the general coordinate transformation are non-linear. Okay? In general, they are non-linear. Okay. So if I look at this very object, now this is symmetric tensor. Okay? This is symmetric under indices. Under indices exchange, sorry, this J and K. So if you interchange J and K, so now look here. So this metric tensor is symmetric. You interchange J and K, it will be same as, it is equal to Kj, that will be same as Gk, Gjk. So now look at this very object. This also symmetric. You are having Jk here, and then you are having Kj here. Is it? So this object is symmetric. So when you interchange, it will become Kj. So this will become Jk. Got it? So both the terms are the same then. Okay. So what it means? So I am having like this. Gamma I. Okay. So this very important property. Okay, this symmetric property. Now let's look at the transformation rule. No? Okay, transformation under general coordinate. Okay, under general coordinate transformation. Transformation properties. How it transforms. So now I can write this in the primate coordinate system. Let me write I prime, okay, gamma prime. So it is half of G prime IL. So it is minus partial prime L G J K prime, because everything will change under coordinate transformation. It's the coordinate transformation. That's why. So you are having prime G K L prime plus partial K prime G prime L G. Okay. So this is how they will transform. Okay. So now let's look how it looks like in the unprimed coordinate system. Okay. So now tell me. So you are okay. So let's call this as equation first. So I will evaluate only few terms. So you do the analysis. On notes, everything will be derived correctly. Okay. So let me evaluate only few terms. Then. So let's write how this looks like Gi prime L. So it is actually a contra-guaranteed tensor of rank 2. How it goes? So its prime means up. So I by partial x prime L by partial x. Then you write a contra-guaranteed tensor of the same nature. So let's put a B. So you write A. Okay. So A, B are contracted indices. So now let's look at the derivative. So remember this very formula. So let's call this as second. So we need to okay, one more point. So now how it looks like this partial prime L. Anybody? So it's actually partial by partial x prime L. How it goes? So it goes as partial x, let's say A by partial x. Anybody? Partial x prime L by partial x. So what is that? So partial x A by partial x prime L partial. Okay. So remember these things. So we can use the different indices as well. So let's take this term, whatsoever is inside. So let's take these terms. So I'm having, okay, so partial prime L G prime JK plus partial prime J G prime KL plus partial prime K G prime LG. Okay? समझ आया? So now let's evaluate this thing. Okay. So this is equal to minus partial prime L. So let me keep this partial prime as such. So what is G? How G transform? So this is actually lower two indices, is it? So is it correct? So what is how the lower indices transform? G prime IL. So it is what? Let's say GAB partial XA by partial X prime I. Okay, then partial XB by partial X prime. Okay, so keep these two indices in the lower. If you are having prime, prime it means down. Okay. समझ आओ? So what you are having? Now let's write. So it is GAB partial XA by partial X prime J partial XB by partial X prime K. Okay, so you are having JK here. Then, so plus partial prime J, what is G prime L? So it's partial XA by partial X prime K partial XB by partial X prime L. And then you are having G. So why I have put? Because these are actually additive terms. In the additive terms, you can put the same type of demi indices. Okay, so this will be helpful actually. Then I am having plus partial prime K. Okay, you are having now partial XA by partial X prime L partial XB by partial X prime J. Okay. समझ आओ? So now let's differentiate it. So remember there is a G prime outside. G prime IL is outside and L is a dummy index. It's a sum index. Okay. So now let's differentiate it. So what you are having? Anybody? So now look here. So just look here. So you are having how many terms? 3 terms within this thing. What I will do, I will keep this as one term, this as one term. Okay. This as one term, this as another term. Okay. Similarly there. So this term and this term. Okay, so what I will do, I will use a chain rule, differentiation of this G, then the differentiation of this thing. Differentiation of this thing and differentiation of G. And then I will club the terms. I will put first differentiation of G. So it's minus partial prime A, GAB. From this very term, I will put the differentiation of G. GAB. Okay? So wait a second. So there will be this term outside. So minus partial XA by partial X prime J partial XB by partial X prime K. Then the differentiation of what? GAB. Then you are having this objective partial XA by partial X prime K partial XB by partial X prime L. Differentiation of this G. Clear? Then similarly here partial XA by partial X prime L partial XB by partial X prime J, then differentiation of what? G. How many terms you are having here? 3 terms, is it? So now there will be actually differentiation of these objects. समझ आओ? So then you are having like this thing. Minus GAB will come out. Then the differentiation of partial prime L, okay, partial XA by partial X prime J, partial XB by partial X prime K. Then you are having plus GAB partial prime by partial prime what? J. Okay. Then you are having this partial XA by partial X prime K. Then you are having partial, just to remember, okay, so keep track of these indices, it's very important. Then you are having GAB partial prime K partial XA by partial X prime L. Then you are having partial XB. Okay, so these are the rest of the 3 terms. So समझ आओ? What I will do, I will only evaluate these terms. Now you see under the differentiation, you are this gamma factor contains these derivatives of G, is it? So that means you will get gamma from these 3 terms. These Christoffel symbols contain what? Derivatives of the metric tensor, is it? So see, where are the derivatives of the metric tensor? These 3 terms, correct? So that means they should yield me what? The Christoffel symbol. Now you are having additional terms here. So now from this equation you should see, so these Christoffel symbols does not transform as a tensor because you are having the additional terms. The way we are having the partial derivative of a vector does not transform as a tensor. Correct? So you had the first term which has a well-defined transformation rule, then the second term which does not have a transformation rule. Correct? So similarly, you are having the first term with the well-defined transformation and the second term which does not have a transformation rule. Correct? So that means, so this is the sum of two terms. It means this Christoffel symbol does not transform as what? Tensor. Now let's look at these very terms. So let's call this term as 1. Okay? So this term as what? As second. So I will evaluate only the one term. So you will see, and I will put directly the result of from the second term. समझ आओ? So let's do it. So this I don't prepare now. Okay, so let's look at these terms. So 1, it is equal to minus partial xa by partial x prime j. Then you are having partial xb by partial x prime k. Now tell me how this will transform this partial prime. Anybody? One minute. So partial prime L. So it's like this: partial by partial x prime L. So how it will transform as? Let's say partial xc by partial x prime L and partial by partial x c. So because a and b are already as a dummy variables in our equations, so I will use now c. So it will be something partial xc by partial x prime L. Then you are having, so from this very objective. So this objective. So let me write it. So there partial prime, okay, L GAB I can write as partial xc by partial x prime L, then partial c GAB. Okay. So it will be partial c GAB. Now let's take the another term. You are having partial xa by partial x prime k. Then you are having partial xb by partial x prime L. Then now let's look at this thing. So this I can again write. Now tell me partial xc by partial x prime j, because there is a j. Then you are in partial c g a. Then the last term plus partial xa by partial x prime L. Then you are in partial xb by partial x prime j. Then this I can write partial xc by partial x prime k, partial c g a. Can I write it? Clear? Now look here. So I want to make all these three factors to be same. समझ आओ? So what you are having? Partial ax by partial x prime j, partial xb by this thing, partial xc by this thing, is it? Now let's look at here at this very term. So what you are having? Partial xa by partial x prime k. Clear? So why this is k is at b, is it? So this is a differentiation of xb with respect to x prime k. This is a differentiation of xa with respect to x prime k. I want it what? xa by x prime j, is it? So that means, now look here, if I interchange, let's say a, b and c in this very thing, so what I will do, since a, b, c are dummy variables, okay? A, B, C are dummy variables, okay? So that means I can interchange them. So dummy variables means the index on which there is a sum. You can replace them in alpha, beta, gamma, I, J, K, whatsoever, eh? Okay, any arbitrary, yeah, this thing. So what I will do, I will replace this A by B. Let me use this A, use this thing. So this I can put like this thing. Partial x, let me write it. Partial x prime k, partial x by partial x prime L. Then I can write partial x by partial x prime j. Is it? You are having partial g. Clear? Like this. Now take a look. What I want to take, I want to put here b. Is it? So that means a is replaced by what? B. So you are having b here. Clear? So now what you are having x prime L, it is c. So here it was actually b at this very point. That means b is replaced by c. So b is replaced by c. Now what was here? B. So this was A, so you are having here what? Sorry, A.
So C.
C is replaced by A. So this is C. C is replaced by A. समझ आओ? So now you see the overall factor is same. So whatever factor you are having here, that is same there. Clear? समझ आओ? So now let's look at the third term. Okay, so let's look at the third term, this very term. So now what I need to do? So let's do it. So you are having x, okay, x prime L, it is here. So that means this A is a dummy variable, it has to be replaced by C. So I can write this thing as partial xc by partial x prime L. So let me write like this thing. So A is replaced by C. Okay, then you are having partial, okay, so prime J, J means B is replaced by A. So this is A, partial x prime J. Then you are having the C is replaced by B. Clear? So it is simply the interchange of A, B, C indices. समझ आया? Everybody had got it? Everybody is following it? Okay, good. So now let's look. Therefore, this I is equal to, now I can take the factors out. Huh? So this is, okay. So I can take this partial xa by partial x prime j, partial xb by partial x prime k, partial xc by partial x prime l. Is it? So what remains inside? You are having minus partial c gab, then you are having the another term partial a gbc, then another term partial b gc. Do you see? It is actually the Christoffel symbol. This inside. Do you see it? Do you see it? Huh? So you need to put actually half, is it? So because the Christoffel symbol carries. Okay. So now let's take that very term, because there is a GIL in front. Is it? So that we need to multiply. Okay. So let's take that. So everybody has written it. That G prime I L and half is sitting. So let me take this I. Huh? Because first is what? This very term. Huh? So that's equal to half of G. What is G prime I L? So let me write first. G prime I L. What is your I? So it's partial x A by partial x prime J, partial x B by partial x prime K. Then you are having partial x C by partial x prime L. Clear? So then you are having minus partial C G A B plus partial A G B C plus partial B G C. Okay. What is this G I prime? Okay, so the another term is what? Half of G prime I L multiplied the second. Clear? So this is simply the symbolic representation, you can say. It's symbolic representation. Right? Because this does not carry index. You can put the indices. Right? I just put I. Right? Okay. So what this object is? Can anyone tell me? What is this object? So it's partial x prime, x prime I by, let's say, partial x e c d. Let's write d. Then you are having partial x prime L by partial x e. Then you are having g. Clear? Samajha? Because I already used ABCD, ABC. Now I will use DE. So then you are having partial XA by partial x prime J, partial XB by partial x prime K, partial XC by partial x prime L. Then you are having minus. Okay? GC is partial GC. Okay? Now, tell me on which index in these derivatives there is a sum. There is a sum over which index? L. L is a repeated. Look here. You are having L here and L here. Is it? So it means you are having this very factor and this very factor. So there is a sum over L. So it's like this thing. Sum over L, partial x prime L by partial x e partial xc by partial x prime l. So you can cancel the two terms. So because there is a sum, they are the same things. Okay, all the terms are the same. It will be simply partial xc by partial xe. So that's equal to delta c. So so you cannot say you can cancel any other terms. So there should be sum, because only under the sum you are having this out. So now you are having delta ce. Okay. So now look here. So let me write. So you are having partial x prime I by partial x d. Then you are having partial x a by partial x prime j. Then partial x b by partial x prime k. Clear? So then you are having delta ce. Okay, minus partial c gab. So there is a g as well. G d. समझ आओ? So there is a g d. This g. So plus partial a g b c partial b g c. Now let's sum over e. Since there is a sum over e, e is a repeated index. It's a sum over e. That means e will be replaced by c. So समझ आओ? So what you got? And there is a half as well. Half is also. So it is simply partial x prime I, partial x d, then partial x a by partial x prime g. So e is here. E and e gets contracted. Okay, so I will write g d c. Okay, and half I will write like this. Minus partial c g b is partial g b c. समझ आओ? Now what this object is? Anybody guess? So GDC, C is contracted, AB. So it's a Christoffel symbol, is it? समझ आओ? So therefore I can write okay. So therefore I can write. So this is simply equal to, let me write, partial x prime A by partial x prime I by partial x d. Then you are having partial x a by partial x prime j, partial x d by partial x prime k. So this is simply gamma. So it is d. So d is up. Then you are having a. D is contracted. A b is contracted. What are the indices? I is up. J k are down. So this comes from where? The first term. The second term also contributes. So you are having. So the second term is, can anyone tell me? So half of g prime I L, then you are having that second term. So that also carries something. So let me write the result directly. So when I add the two terms, so it looks like this thing. So let me write the second term yields this object here. So let me write. So it is something. So check it. So it is minus. So it's very simple to check. Partial x d by partial x prime j. Then you are in partial x e. So let me write it. Let's write e. Partial x prime k. Then okay, this is the second term giving the result. Now, therefore, I am having my this Christoffel symbol. They transform like this way. So I j k. So under transformation, so it's partial x prime I. Now look here. If the transformations are linear, then the second derivatives cancels. This goes to 0. So this second term does not contribute. Then it's what? A tensor. So what are the linear transformation at here? These are the Lorentz transformation. That means Christoffel symbols will transform as a tensors under Lorentz transformation. But under general coordinate transform, they are not the tensor. So it's like this. Okay, minus partial xa by partial x prime j partial xd by partial x prime k. Just remember this way, this form. So this the first thing is easier to remember because you have to put the transformation rule for each index. Okay, then you are having this very term. This transformation partial x a. Okay, differentiation with respect to this j, differentiation with respect to this k. Then you are having the double derivative of this I. So those dxa, dxv you have to put here. So this is a simple way to remember this transformation rule, and there is a minus sign. Okay. So we'll see actually it has a lot of importance why it has to transform this way. Because ultimately our goal is to figure out a derivative that is invariant under a general coordinate transformation. Okay. So when you make a coordinate transformation, the nature of the derivative should remain same. It should act as a derivative. We call those as the covariant derivatives. This gamma helps us to construct those derivatives. So tomorrow we'll see at 9. Let's have at 9.